Supervised learning is used whenever we want to predict a certain outcome from a given input. While predicting these outcomes, we encounter two major machine learning problems: classification and regression. In classification, the goal is to predict a class label, which is a choice from a predefined list of possibilities. It's a task of predicting a discrete class label or category for a given input. Classification is sometimes separated into binary classification, which is the special case of distinguishing between exactly two classes, and multiclass classification, which is classification between more than two classes. Examples of classification problems include email spam detection, image classification, and sentiment analysis. Regression, on the other hand, refers to the task of predicting a continuous numerical value for a given input. The goal is to learn a function that maps inputs to their corresponding outputs. Examples of regression problems include predicting house prices based on features such as location and size, predicting stock prices, forecasting weather patterns, and predicting a person's annual income from their education, their age, and where they live. An easy way to differentiate between classification and regression tasks is to ask whether there is some kind of continuity in the output. If there is continuity between possible outcomes, then the problem is a regression problem. And if there is no continuity in the output, it's about either X or Y, it's about clear categorization and classification, then it's a classification problem. At the end, both classification and regression are related to supervised learning, where the model is trained on labeled data to make predictions on new, unseen data. But they differ in terms of the type of output they produce: discrete classes for classification and continuous numerical values for regression.